do something first, right? It gives you 3 points. What are the 3 points it gives you on this one?
1, 1, 1.
Thank you. 1, 1, 1. Yep.
1, 4, 5.
1, 4, 5, and what?
-3, -2, 0.
Thank you. So what's the first thing it asks you to do on this question?
Find the plane.
Find the plane, and you've done that a few times, right? You find a couple displacement vectors emanating from the same point, you cross them, and you get the normal vector, and then you pick one of the points. So if you do that out, the equation of the plane, you might get something that looks similar or identical to this. So this is the equation of the plane that goes through those 3 points. Anybody get something vaguely like that? You might have gotten some linear combination of the normal vector, depending on what order points you picked. Are we okay so far? Do you understand how you get from these 3 points to that equation right there? So then it asks you, no, it should not matter which point you pick. It should reduce to this, theoretically. Now, it then says find the distance between this plane and the point. What point do they want the distance to? Well, that's kind of nice, isn't it? I mean, it makes it a little bit more. It doesn't really change the math too much. It cleans it up a little bit for you. But the idea is it gives you this plane, and it gives you the point 0, 0, 0. So let me just draw you a general representation of what's going on. You have a plane, right? There's your plane. We'll call it the plane. Yay. Right here. Yay. And then you have a point in space right here. And when they say the distance from a point to the plane, they mean the shortest distance. We're okay with that? Okay. So that means it's going to form a 90-degree angle with that plane. So what does this point, let's call it point P, and it's 0, 0, 0. Now, when you tried to attack this, what's something you guys tried to do? What's something you guys tried to do? And again, the relative direction of this plane is irrelevant. It doesn't change the math, right? What's one thing you tried to do? Or if you had one piece of information, what would you want to have? Yeah?
The angle between
which angle?
Between the plane and the origin. That would form like a right angle.
Well, we know we're just saying that, we're saying that this is a right angle right there, right?
But I mean, going from the origin.
What point would you like? Okay, I'll label some points here. Let's just I'm going to call this D, and we'll call this E right here. And E represents any point on the plane, okay? You could rotate it around. If you had D, you're done, right?
Yeah.
But it's not so simple. I mean, this is an Algebra 2 question I give out all the time. Well, not right now, but I have in the past. You have 2 lines that are parallel. What's the distance between them? It's not trivial. It takes a little bit of work, right? You pick a point here. You find the equation of the perpendicular line. You find the point of intersection, right? And then you calculate the distance that way. Okay, so let's go back to our picture here. And I gave you a really strong hint here. So the thing is, if you have D, you're done. Do you agree with that?
Yeah.
The challenge with that is that, do you get a sense that that's probably not how we're going to go about doing this question?
Yeah.
It's probably not going to be how we're going to go about doing this question. Okay, so I said E was any point on the plane. Can you start seeing something that maybe relates to something we did in this section? What are the 2 big things we consider? What are the 2 big new topics from this chapter?
Dot product.
Dot product and cross product, right? Well, let's look at dot product here. Okay, let's look at dot product. Okay, one thing we did with dot product, we talked about lots of different things, but let me draw something to see if you can see it yet. So let's say you had a vector like this, and that's supposed to be a straight line, which wasn't very straight. Sorry about that. So let's say you had a vector like this, and you had a vector like this. What we're looking for is, let's call this vector, I don't know, let's call it U right here, and let's call this vector V right here. And I'm using the highlighter, and I don't like that, but I just labeled this here, and that Java's going to go berserk. That's fine. What are we trying to find?
Projection of U onto V.
We're trying to find the projection of U onto V. We're trying to find the magnitude of that projection, right? We're trying to find the scalar projection, correct? So, do we have an equation for the plane that black plane at the bottom?
Yeah.
Sure. Can we find like a point, E? Does it matter what E is? No. The projection, as long as it's going through that point, is going to be the same. Are we okay with this truism right now? Do you understand what I'm saying? So, let's just pick a point for E. What point do you want to pick for E? How do you go about picking a point for E, like a value for E? Well, does 1, 1, 1 work?
No.
You can't, because it's got to be true inside this, right? So how about we just try to level it off a little bit? Let's make it 2, because that'll make it 18, and make it 1. Does that really help? I mean, I'm just trying to make it nice. Like, I'm trying to find a nice point. The issue is you could just pick two values for x and y and then solve for z, right? So you literally could make it 0, 0, and then what? Negative 5 over 12, right? You could do that, right?
It's 512. This is 512.
5/12. Thank you. And you know what? Let's just do that, because do you want to spend too much time trying to find some sort of like integer value point? No, don't. You're not guaranteed to have one. So anyway, you have that point. So now what are you going to do? You have that point. What are you trying to find? You want the magnitude of v parallel, right? You want the magnitude of v parallel. Remember, do we have a formula for this? Did we? What was it? Do you remember what it was? Anybody? Oh,
And we have normal vector.
oh, what is v? It's a normal vector, right? Do we have that normal vector? What is it? 9, negative 16, 12, right? 9i, negative 16j, plus 12 what? Okay. Sometimes I don't do the little hats, right? Okay, so how about this? See if you can find it on your own right now. Okay, so if we do this dot product, can someone lead me through what the top, what is, we already decided v, what's it going to be? 5 on top?
Yeah.
And then you need the magnitude of the bottom?
Square root of 481. So
Square root of 481?
yeah,
Huh, I wonder if this
total is 0.23.
0.23. Absolutely correct. That's great.
So that's the distance.
When you're doing any question like this is to understand what the heck is going on. It is not. I think the hardest part of this question is not the math, but the conceptualization, which is part of the math, I guess. The conceptualization of what they are asking about. Here's the deal. Everybody just look up for a second so you can see that I drew out the diagram. What's going on is that you have three things, like 1, 2, and 3, trying to lift something right here in the middle. We're looking straight down at this object. We're looking straight down at this object. North, east, northeast, southwest. Thank you very much. So what you have one force vector here, you have another force vector here, and then you have this unknown force vector here. This is where the crane is going to be. Is everybody with me so far?
Yeah.
You're making the assumption that the object is going straight up. You're making the assumption that the object is going straight up. They want it to lift. Everybody with me so far?
Yeah.
So the challenge is that, okay, so let's analyze that sentence, or that statement. If it's not going to, if it's going to go straight up, what do you know about the I component and the J component of all of these added together? They have to zero out. They have to zero out. So what you have to do first is find the I and J components of this vector. The I and J components right there. So can you do that in a relatively straightforward way? Sure. You have to be careful because the signs matter, but you're going to have 100 cosine 30i plus 100 sine 30j. And then right here, what's this one going to be?
40 times cosine 70.
Negative 70 cosine.
Yeah, cosine of
Negative
negative 80, right? And then you just have to put in negative 80 for this one. Is everybody with me on this so far? Just relative positioning? So once you find these two, you add them together, right? If you add these together, you get an I component for the sum of these two, and you get a J component for the sum of these two, right? That has to be, the opposite of that I component has to be the I component here, and the opposite of that sum J component has to be the J component right there. So what you end up with is the I and J components for this force vector, right?
Mm-hmm.
What do they also tell you about this force vector?
The magnitude.
They tell you the magnitude of the force vector, correct?
Well,
Wait, hold on. Okay, sorry.
solve for k.
Yeah. Squared plus 18.94 squared plus b squared. The square root of that is equal to what? 3,000. So when you do this out, how many answers do you get for b?
2.
Yeah, you get b is equal to plus or minus 2,998.31. So you get b is 2. So why do you get a negative answer on this?
It's square root.
Okay, functionally it's because there's a square root. Yeah, you could be pulling it up or down, right? You could be pulling it up or down. But they tell you want to pull it up. There you go. You're all set. Yes, Henry.
So